yeah, so this is like officially free version of this book, and but the difference between this old version and new version is that new version describes how to build a simple RISC-V CPU, but this starts from chapter 5. So like from chapter 6. So chapters 1, 2, 3, 4, 5 of both books are practically identical. Yeah, so you can start from this simplified version of the book, and like you can like browse chapter 1, 2, 3, 4, and then read chapter 5 to get some like basic idea. And you can also start from these slides. So these slides like demonstrate some basic ideas. So you can like read theory, and then you can run examples, and by using examples you will understand how theory works. So basic idea is that during last like 30 something years, designs are created using hardware description language Verilog and VHDL, and like unlike software which translates like programs into instructions, this path allowed to translate code straight into mask, and now you can use a field programmable gate arrays, yeah, so like in this way, so you can see how code becomes first graph of logic element and then a mask, and you can use field programmable gate arrays to like as a reconfigurable hardware. Okay. Yeah, so as a configurable hardware, and so here I like discuss how engineers work in a team. So like basically inside the FPGA cell we have a structure called lookup table, which allow to create like a universal gate depending on bits in config memory. And this allows us to make a circuit without manufacturing it on a semiconductor foundry. Yeah, so this is like a basic idea, and you can just start reading with the book and then get some FPGA board and start running exercises. So this is like basic idea how to start, and you can send me emails like asking questions about this book. Yeah, but the first step you need to look to different slides. So in addition to these slides, there are some other slides, and once you get some basic understanding of what is going on, then you can get some inexpensive FPGA board and start to run examples and exercises, and then like maybe create your own like literacy design using TinyTapeout service. Yeah, so yeah, so what is your email? So can you put it into chat, so I will just send you some beginner information. Yeah, so now next thing we are going to discuss today is that we have a lot of pull requests, and one of this, so the most important activity today is we need to test a board called Tank Nano 20K, and actually I want Timothy to assemble Tank Nano 20K on breadboard. In fact, let me give it to do this to you right now, while I will talk about like other subjects. So So basically, Tang Nano 20K is the board similar to Tang 9K, but the pins are different. So you need to do git pull and see how pins are organized right now. And based on this information, you need to like assemble Tang Nano 20K board. So let me put all the pieces here. Now, there is one important thing. This board has its own interface to a speaker. So we don't need to use that thing. We can just use the speaker specifically for this board. This is the speaker. So you see, we don't need to use eardrops. So now let me give you all other parts. So you need to have like breadboard, and you need to get female connector. So get like breadboard from here and find other components here. And let's just assemble same thing we did for 10 nano 9K. Yeah, so just like you can find everything here.
It's pinout different?
Yeah, pinout is a very pinout is different. So pins are located in different places. In order to figure out pinout, so let's
I just need to check on mine.
yeah. So just get the latest version. Just get the latest version in a GitHub repository. So let me go quickly through the pinout and the difference in a pinout. So first of all, you are going to see pin. So if you can finalize this configuration in the next couple of days, then I will buy like 10 more of such boards and we will use it during Maker Faire. So this is important. One, yeah, one particularly important news which I want to show like everybody is that we are working with the Govin marketing, and yeah, and let me show you what a Govin marketing person actually created for us. Just a second, let me find his email and his documents. So he created draft, and we need to work with them together and put something final. Just a second, let me find his email. So this like very like time sensitive and critical activity. Okay, just a second. Oh, okay. So let me download all this document and let me show this document to like everybody. This is 1, 2, 3. Okay, rest is okay. Also, let me show you promotional videos I'm going to put into a post. So let me share my screen again in Zoom. So right now I am preparing like a series of articles to promote our event in the Makers Fair. And this is video from meetup in Los Angeles. So this is one of part of this materials. So you see, we like hired a videographer who created such material, and we like essentially assembled the tank 9K board, and we want to do the same thing with the tank 20K board. Okay, so now let me show you materials which Govin marketing person prepared as a draft. So just a second. Yeah, so Yeah, so first of all, they have already this document called Govin EDA Quick Install Guide. Let's do. Oh no. So yeah, so they have already this Govin EDA Quick Install Guide. So they put like features, how to download, and he put setup for Windows and setup for Linux. So we need to go through this material and find here like any like mistakes. So I will probably go and do some first pass, and then I will ask like every of you to go through this thing and to review such material. So this is setup for going. Second is that board setup, and here so they so he put like our pictures how like assemble 10 nano 9 board. Here I think what we should do is that we should ask him to also put instruction how to add LCD screen.
Mhm.
Yeah. So next also he put some draft instruction for 10 nano 9K programming setup. So how to get like Git under Windows or use Linux, how to clone repository and so on. So I will go through this text and just make sure that like everything here is correct. But this is essentially a flyer we are going to give everybody during Maker Faire. Yeah, so once I do first pass, I will share, and so like everybody can like take a look and edit this document. So I want to create version for 10 nano 20K as well. So this is what came from them. Now, if we go to now if you go to 10 nano 20K, 10 nano 20K, you can see some pins here. You can see pins here, but I actually extracted pins from Govin examples.
Mhm.
So in order to extract pins from Govin examples, I simply cloned a repository. Going repos. No, it's not this one. 1 second. Coin repos, or is it in project? Ah, yeah, it's here. 10 nano. No, it's not this one. So we are going to GitHub 10 nano 20K examples. Yeah, so we are getting this repository called 10 nano 20K examples.
Mhm.
Then we get like then we clone it, so we can clone it somewhere. So let's go like going yeah, here 0. Yeah, so let's clone it here. So git clone 20K examples. Yeah, so essentially what you do after this, you can just find all CST files. So you can do find the name star CST files, and you can see files with the pin definitions for different examples, but not all of those files are actually good files. Like this NAS tang is probably imported from another project.
Mhm.
Yeah, so if you do like xargs like get to Z. Yeah, so you can see pins from all those files, but not all of these pins are correct. So just a second. Yeah, so like you can see that these pins which start from a letter, those are pins from a different board, obviously. So this is probably from 1020 primer. So what we can do is that we just get we just put like all files into some like file. Let's call it like Z1. Then we look into wait. You can actually look at them. Yeah, so you see, we can extract pins for LCD from here, and we can extract pins for like other things from other CST files. So like I combined all pins in one file, and then I look to this website, to Tank Nano 20K website, and like I edited this file, and then like I asked Alexander Ryabov to like update Tank Nano 20K board support.
Was it merged?
So here, yeah, this merged. So this is already. Oh wait, I'm not sure was it merged. Let's actually merge it right now. So because it's not merged. So let's actually go and merge this pull request, and let's see what he put there. So we have now like a lot of pull requests. Yeah, we're also going to discuss pull requests from Philip. So this is refactoring pin planning for Tank Nano 20K. Yeah, so those are files, and let's just review pin assignment, and then you will start to assemble this thing.
Could you scroll up and disable highlighting white space?
Here?
Hide white space.
Yeah.
Then it will be look more readable to me.
Sure. Yeah. Okay. Okay. So first of all, we had already some Tank Nano 20K support before, but that support was actually connecting to VGA, and it was not precise everywhere. So now we added LCD screen, and we added HDMI, and we added this native speaker. So speaker for this board instead of external one. So now we have LCD pins, and we have and LCD pins are commented in configuration called Tank Nano 20K HDMI. So, and we have another configuration where it's not commented out, and then we connected TM1638 and the microphone in a kind of tricky way. So TM1638 is occupied pin 86, 72, and 71. So 71 and 72 are actually originally were intended for a joystick. So 71, 72, 86. So if you look here, so here 71, 72, 86. So those three pins, 1, 2, 3. You see? And if you go to like our setup for 10 nano 9K, you can see that our setup is somewhat different. So it's similar, but this is different. So, oh, wait. Here we actually put, yeah, here we actually put, here we actually connected TM1638 in this area, but we don't have enough pins in this area, so we put the only microphone. We connected TM1638 to the right, to pins on the right. So you can see that we connected TM1638 here 71, 72, 86. Yeah. Now, if you look to wait a second, where is our, yeah, so now if you look to INMP 441, we have pins 73, 74, 75, 85. And some of those pins are not used, and one is connected to like SD card, but we are not using SD. So we are instead using pin which was intended for SD. So 73, 74, 75, and SD. So those 4 pins are exactly the same as in 10 Nano 9. So we are connecting microphone to pins 73, 73, 74, 75, 85. And we connect the TM1638 to 86, 71, 72. And then we are using connection to its own speaker using signals I2S left right clock PA enable I2S BCLK I2S G IN, but we don't need to connect anything externally. We just connect the speaker to those two little holes. Yeah, so basically what you need to do right now is you need to assemble something very similar to what you assembled with 10 Nano 9K before, but you just connect TM1638 from another side, and you connect microphone in the same place, and you don't connect the soundboard. Yeah, and like after this, we need to test 2 configurations. So one is called one is for HDMI, and another is for LCD, because LCD pins and HDMI pins, they conflict with each other. Yeah, so now we need to test it. So then also one change which I made, and let's see whether this change is reflected here. Like another change is I added generated reset on power up. So if it's not here, we need to like insert it. Okay. So P enable.
Yuri,
yes,
this
this is it. Yeah,
configuration
okay.
contains such reset, but it doesn't show in this commit.
It doesn't show in this. So can you make another, or can you modify pull request to just show it in?
No,
in this
it's
commit?
already present in the previous version, and therefore in diff it doesn't show.
Okay, this is fine. Yeah, this is fine. So this is just in a different commit. Yeah, okay, this is fine. So wait, let's go back here. Okay, so this is. So let's like accept this version and let's start doing it. Okay, this is one thing to do. Okay, so this looks fine. So we have two key and we two native keys. Okay. One thing is yes, Alexander, but HDMI has 8-bit per channel. So you should put here 888 actually, and LCD has 565. So I think that you confused and you put into HDMI 565, but we need to put 5665 in LCD. But for HDMI, we need to put 8-bit per channel. Yeah. So
I can
let's
fix it,
yeah,
but
we can fix it right away here. So we'll fix it. So the colleague Timothy can fix it by himself and test it. Yeah. So we create additional clock here, and we yeah, this like this should be changed here. So we should put here proper proper like W. Yeah, so we can put same thing here, but in this configuration we actually start numbering from 0. Yeah, before numbers started from 7 like down to 3 or 4. So in this particular file we actually start LCD pins from 0. So 0, 1, 2, 3, 4, 5. So we will change. Was this cosmetic change?
So the other pins, they are grounded in LCD monitor.
Which pins are grounded?
The other, up to 8. So 5 connected, and
The ground, yeah, this is fine.
they grounded monitor.
This is fine. This is fine because we are because this happen outside the PGA, so we don't care. Yeah.
Okay.
So this all happens outside the PGA. Okay, so what we are going to do now? What we are going to do now? We are going to just accept this change, and then like Timothy can start testing it, and yeah, this is like one task what has to be done today. Yes, another task we actually need to test. We need to test another board which was also updated by Alexander Ryabov. So this board is called MOCC board. And let me get this board. And probably like I will ask Yuri to test it, to like assemble and test it. Yuri?
Oh, yes.
There is a new task for you.
Yeah, sure.
So let me show you this board. This board is called MOCC board. So let me just give you this board. Yeah, it's this one, but let me give you all the pieces. So this is something. What has to be done as soon as possible, because there is a teacher who wants to teach children how to work with FPGA, and he has this board. Yeah, this one.
Yeah, I bought bigger laptop. Okay. Oh, interesting.
Yeah. So come here. So I will show you how to. So I will show you. So this is your task for today. So both like you occupy, then like I will deal with the pit. Oh, but before this, I need to talk to Philip. Okay. Second task is this MOCC board. So let's see what Alexander Ryabov did with this board. Okay, so
That's a little bit
He
dangerous.
and wait, Alexander, why did you change why did you change naming?
I changed naming because I consider this naming does not proper follow our code style, I think.
No,
Or
but this original naming, we should use naming from the vendor, and then we need to like change everything in then we need to change everything in the wrapper. So I prefer to get naming for the pins from the vendor. And in this particular case, I think I got this board like I got this board specific pins from a company which made it, and it was just following their name. But I'm not sure. Let's see.
it's okay, I can refactor it later and send pull request again.
Yeah,
Or
this
we
is fine.
can
It's
prolong
not
this
a,
pull
it's
request.
not a problem. It's not a problem right now. Just I need to find where I found this name, because I want to follow original name generally.
Yes, but
Particularly
but
particularly here we have different polarity for signals.
That's all the keys.
Yes, this is fine. Let's keep it right now, and then I will just find where I found this original file, because I don't remember. Because you see, my like general approach is that I'm just getting XDC.
It's okay
Yeah.
to pick a microphone from here. I need
Yeah.
microphone.
Just get the microphone from here. So I just prefer to get file with the pins from like Terasic or from Digiland or from other companies, but this is a board from I got from AliExpress or from like MOCC. So let's get AliExpress board, and let's see where I got this board. Yeah, we can do this later on. Let's just accept it right now, and then we can refactor if you find the original board. Okay, Yuri, please like take a look, because we are going to like accept this changes right now. Okay, so like Alexander changed those pins. We may want to like undo it, but it's not a problem. So clock megahertz, he added pixel megahertz, the number of keys, eight keys, 8 switches, 16
You can see
16 LEDs, 6 digits. Then we have oh wait, why did you put just 8 GPIO? Because it has tons of GPIO.
because I cut all unused GPIOs from configuration, because 8 is draft, I think, basically. And probably I maybe need some refactoring.
because we need to
Yeah, I prefer to keep maximum GPIO. The reason for it is that like I want to ask user to add his own peripherals when he is going to like add rotary encoder or like ultrasound distance meter. So like I prefer to keep GPIO as like regional GPIO, but we can add this later. So this is fine. We discuss it later on. Okay, so now we have VGA definitions, which is correct. So now we have clock, key, switch, LED. Yeah, now like basically we just need to test that this whole thing works. You see, so 7 segment. Okay. Yeah, this seg and gig came from another wrapper. So basically, I didn't invent this name. It came from something else. So let's see where it came from.
Yes, I take this name from probably Diet and Nana.
No, the point is this is a
Oh, D10 nano, but D10 nano has nothing to do with this series of boards, because this is not Jurassic boards. So and the D10 nano is a Jurassic boards, and like everything here was oh wait, but this doesn't have deep, it has hex. Ah no, it doesn't have hex.
Probably maybe another version.
Okay, let's see.
Maybe the Yet and Light.
Grip. Yes, yeah. So we have in Zero we have digit N. Ah, this is in RZ. So in RZ we have digit, in peace words we have digit, in Zero we have digit N. So and in AMDAS we have digit. So you practically just wanted to follow AMDAS. But I think we should undo it, because if you go to original board, so let me find it on AliExpress. So this is Cyclone. Yeah. So Cyclone 4 FPGA board. Yeah, it's this one. This one. So this is the board, and let's see specification, view more. I remember I found it somewhere. Description, store. So ammo. Ah, let's actually look to the file because I usually put a note where I found it.
We also have a pin.txt file for this board.
Ah, yeah, pin text. Yeah, so this is I found it somewhere, but let's see where exactly I found it. Huh. Oh, yeah. Yeah, this naming is slightly different actually here.
And when I do this work, I think what pin naming for this configuration isn't so readable, because they just added all GPIOs into three spaces of GPIO, and this wasn't really convenient for for usage, because we have just a lot of GPIOs, and probably for future work it will be hard to maintain this configuration. And this is one of reasons to change naming.
Wait, wait, can you actually repeat? So what is the difficulty with this specific naming?
Basically, I think what naming of GPIO for card config isn't really good, because we have free wire with a lot of GPIOs, and for future maintain of this board it will be hard, I think. And therefore I decide to split these GPIOs into some smaller part, like pins for VGA, pins for VGA, and pins which are used for INMP, for microphone, and I cut.
Ah, I understand. So you just created your pin assignments, but the thing is that my kind of idea how like I was putting it in different boards is that I put in a QSF naming from a vendor, and then I put I mapped vendor names to like our names inside a board specific top wrapper. You see? So basically we keep vendor so that people who are familiar with the vendor, so if they want to switch, if they had their own examples and they want to switch to like our examples, they can see in the QSF file their familiar naming from the vendor. And they know that vendor intended some pins to be GPIO, not like VGA pins. And then we are
Yes.
mapping vendor pins into our pins in board specific top. So our mapping is here. So, but you just want to move this mapping to QSF file. Yeah,
Okay, I understand.
but this is
This
different how it's done for like other boards.
I
So
think I will work with probably in 2 or 3 days, and then we
yeah,
can
yeah.
test this board and accept pull request.
No, we should like test it right now with what we have. And after this, you can like rework and we test it again because we have the whole file history, so it's not a problem. Okay, so you just assigned, you just did all assigned in QSF file in this case, right?
You can have resources.
Yes.
Yes, so like it looks like this, yeah. I simply want to do mapping in a board specific top and QSF file have it from the vendor. Yeah, so this like just a different approach, but the good thing about my approach is that if people were working with the examples from vendor, they will not be surprised. And we keep information from vendor and have only one point well documented where we do mapping. Yeah. Okay. So but let's just try what we have. Oh, wait a second. But did you keep the same locations for the VGA pins?
Yes, I keep all locations which are present in previous config. For example, we didn't have a
Locations are
location
the same.
for maybe microphone
Sound?
or
No,
INMP.
we try to. No, we have
Sound. Yes, NMP. So we didn't have location for the sound output. Yeah, and we did have location for microphone, but not for sound output. So let's see. Yeah, so we had for microphone. So you kept the same location which was there before, right?
Yes.
So here is the same location. Okay. Oh, wait a second. Pin names. Pin names are actually on the board. You see? If you look to the board, if I make a photo picture of the board, the pin names are simply written on the board.
Okay, so this one.
Yeah, so this is another reason not to like mess with the name.
That's the natural.
Okay, anyway, and looks like for digits we are using negative polarity, so that's why switches N and so what is the lab key?
I used 1K for one of the all keys as a reset key, and they have this done under the module module stub. A bit down, probably.
Lab key.
Yes, lower than laptop.
Here.
Yes, here. Oh, yes.
But in this case, you need to put here complement and not put complement in there. So you like either use complement there and you don't put complement there. I mean,
I add complement for lab K in top module instance.
I understand, but like basically in all other boards, if we need to like complement something, we add complement here, so that lab keys are always have a positive polarity. So when we have something with like lab underscore something, this lab underscore something we expect to be positive. So when you push, it's 1, and when you don't push, it's 0. So
But
this
I
is at least
have
how
this.
this is in other boards. Huh?
I have these elements, but they are written in another place.
Yes, but for a person who look to like other boards, this will be confusing, because
But
he like
but
expects this signal is going after complement, and then you actually use this with a negative of polarity signal.
But
You see?
if I write negative signal here in the module
Yeah.
instantation, I will
Then you to
meet
remove it there.
I meet a similar situation when I have negation for one signal and do not have negation for another signal.
Wait, so basically, let me show you the logic behind this.
No, Yuri, I understand what you wanted to
Yeah.
to
So
make understandable for me, but can you please open my version on iLaptop instance, and I will show you the difference.
yeah, I think I saw a difference. Okay, let's just open your version. Yeah. So
Yes,
you're talking about here, right?
yes,
Yes,
I
I know
talk about
that you put negation
labk,
here. Yeah.
and I do
Yeah.
negation here because if I move this negation down to the wire instantation
Yeah.
where I do splitting, here
Yeah.
I do not have this negation, and it can be confusing also.
No, this is not confusing, because this is the lowercase lab key, and lowercase lab key are already supposed to be normalized. This is supposed to have meaning for the laptop. So here
Okay.
we should have here same as laptop. So everything lowercase with lab prefix is supposed to be already converted and normalized. That's
Okay, I
why
understand.
here, when you have switch with switch here, but this switch is a capitalized switch, so it's coming from outside vault, and because it's coming from outside vault, it can have different polarity, and in fact we can name it switch N to make it more clear. So on the board it's called simply switch. So basically all over code, when we write something with a lowercase, and especially with the prefix lab, we assume this is already normalized signal. So
Okay,
this
I
should be
got
like a lab key here, lab LED, and then if an external signal has a negative polarity, in this case we need to convert like key into lab key somewhere else.
okay,
And
Yuri, I got
this like idea
your
behind
point.
like design in like other places. Yeah.
And
Just to
this
keep it
place,
confused.
yes, I got.
We can.
Yeah, but let's like test what you have right now, and start from there, because we don't need to do this all in one iteration. Let's do this in multiple iterations. So let's do merge pull request. Let's do confirm merge. Okay, so now, Yuri, so you're getting this thing, you're getting those parts. You can look into file QSF. So let's do git pull.
Yeah, I did on my machine. You can.
Yeah. So yeah, you can do a git pull, so you can get this like most recent thing. Okay, then what you do is that you look into QSF file, and you find how different pins.
So boards, I'm
Yeah.
For image machine.
Oh wait, where did you get pins?
Yuri, one
Oh,
remark.
yeah. So can you send this? Can you send this link to the chat? Yeah, we have. We found actually a location of. We found location of the document. Yeah, we got it from a document. I was doing this with Alexander Mikhailov. Just second. Oh, but actually naming here was even different. You know, maybe we'll keep your naming because their naming was also different. Okay. Can you wait? What are you trying to do?
No, if you can.
No,
Okay.
you want to share your screen? Yeah, you can share your screen. So let you share your screen. So let's Victor to share his screen, and he found this document. Yeah. So yes, Alexander, we can keep your naming because looks like your naming is as good as naming we had before. I think this wrapper was implemented by Alexander Mikhailov before he went to Apple as a contractor and disappeared eventually. But okay, let's find
So what's the problem?
We're trying to run this synthesize.
docs.
It says here that we are missing
Are you using the right branch?
the right branch. Oh man, okay, let me try that. And let's try that.
You have installed Bowin ID, right?
You don't have it, right? Corwin? Okay, first let me try to get the latest branch.
You need a new graphics branch. Okay, first of all, let's find yeah. So Victor, can you show your screen? If the document is not large, let's put it here.
You can tell how to find it.
How to find it?
If you go to www.emocc.cc,
Wait, what is the name of this thing here? Look, I already forgot. So yeah, emoc.cc. Yes, emoc.cc.
We're gonna switch to
Okay.
okay, you should add W in front.
Okay.
Google doesn't like it.
we are at the latest.
www.
We're gonna pull from the remote.
Yeah.
Okay. So
Okay,
now
next.
let's say English and browse here. I mean, click.
Just a moment. Yeah.
Yeah, this one. Okay, one more. Okay, click here.
Yeah.
Okay.
Just
Now you translate to English.
yeah. Just a second.
Translate to English. Okay,
Yeah.
and here it should be FPGA, something FPGA development.
Product information.
Development,
Yeah. Development.
I think here. Right? Okay, and
Let's find it here. Development board. Oh, maybe it's here. Altera, yes, Altera Cyclone 4 development board is this one, right?
yeah, general instruction for mini.
Product overview. Here, FPGA catalog. This one? Basic board information. This one.
Yeah.
General introduction, mini FPGA. Yeah, okay. So we need to put we need to put this link into QSF file. So git full. Okay, so we need to put this link to QSF file. So we need to put here. So based on. So this file is created based on. Okay. And
Which one is man okay? Okay.
No.
But
Which one of the old versions?
yeah,
Because there is a
Yeah, no.
LTE, check it out.
Yeah, it's very good.
yeah. So you can actually get key from here, but what is called key in, key switch in, and so on. LED out, then it's got Digitron CS. So we change it to something else. So we can change it to something else.
And you don't get
Yeah, buzzer and then like GPIO pins.
72 and 800 by 400.
And then we
800
have
by 400 is that big one?
okay.
serial
So
and
it's one.
EEPROM
All guys.
UART. Okay. So
Now
what
we
I
have variations
propose to
no,
do is
and this EMC that you
yes, Alexander. So if you want, you can become like owner for this board, and then like work with that professor, name it as you wish. My only recommendation is to keep it consistent. So let me put this comment, and let's try it right now. And instead of seg and dig, yeah, you can keep it seg and dig if you want.
For me, it doesn't matter, to be honest, and we can change it in any name which are understandable for people who read the config file. I think it's the main property of such names, because names like GPIO J7 isn't give me understanding of what is being presented for.
Just a second. So is there any J7 here? I just need to find out why I came with this name, or maybe like Alexander came with this name. I don't remember. So, but what was there before? There was like Alexander Mikhailov. So, 1 second. What was there before?
Yeah, there is J2.
Yeah.
J7? Or what?
So there is a J7. Yeah.
No, J2.
I know, but
looks
this is
the
the
same.
pin name. This is the pin name. We are looking not the pin name. We are looking to the whole group of pin name. So file changed. Okay. So here you had GPIO P1, GPIO P2, and something else. Yes, there was a GPIO P1 and GPIO P2. I think this is names of the headers. Yeah, so you can look to this manual. So let me just put this link to the chat. You can look to this manual and then come with any pin naming as you wish. But we need to keep two things. First of all, we need to give user all the GPIO possible. So this is like first thing. So we need to give user all the GPIO. And second, it should be consistent with some another board. So if you want to make it consistent with MDAS, it's okay. We can keep it consistent with MDAS. Oh, and another thing that if you do any like negation, like any complement, this should be done before lab top or lab key or lab something. Yeah.
Yes, I got this idea, and before I think what it isn't really matter, but now
Yeah,
I
I understand.
understand the ideology probably of this naming, and it makes sense, I think.
Yeah, okay. So like a lab something is really like cleaned up signals. Okay,
Yeah.
so I think that we are good here. Okay, so Do you understand how to figure out pins and QSF file?
Look in the code base and
Yeah.
things from
Yeah,
the
yeah,
website.
yeah. No, you can read pins on the board.
Mhm,
Actually,
mhm,
all
mhm.
pins are here.
Mhm.
So you just look to like a QSF file,
Mhm.
and you connect everything together. And
Like big picture. What should we?
yeah, let me show you a big picture, because I had a photo picture of this board before I gave it to people in Azerbaijan.
Yuri, can I say you one remark?
Yeah.
For now, I think it's better to use lab board specific file, because I put all pins here into lab or not lab but board specific system Verilog file, and it is more clear for understanding than QSF file.
Okay, yeah. Oh wait, but you put VGA pins here.
Yes.
So we should revert it back to GPIO to make it consistent with other boards, and just to put here GPIO and put VGA in there, because if people are reading this document, because if people are
Yes,
reading the document,
Yuri, I
they
think
VGA pins. Yeah.
I spent some time for refactoring of this config file, and probably I go from specific VGA pins to GPIO, and I
Yeah, I got it.
just leave some comments which show what these pins are related to VGA, but if you want, you can try to use them.
Yeah, and then we do mapping in the code. Yeah.
Yes, I got this idea, and I will refactor probably in
Okay.
2 days, but in the worst case, I think before the next meeting.
Yes, this is fine. Even if you do this in like 2 weeks, it's not like really tragic, because our main sort of like customer for this is that professor from MIFI, who is working with children and want to like integrate this into robotics class. So as long as all like three of us are happy about this, we are fine. Yeah. Okay, this is fine. Yeah, for the sake of clarity, I would prefer to have like underscore n after signals with a negative polarity, but this is kind of up to you. Yeah.
To be honest, I do not want to do such research of the schematic of this board, because I'm not really good in I do not know remember word in English, but in Russian it's схемотехника.
No,
And
but this is not actually schematics. This is polarity, which means that when you press a button, if button is pressed is 0, and if it's not pressed is 1, it means that it has a negative polarity, and we need to do complement. So if you need to do
yes,
complement operation, this is underscore n. But if you
yes,
don't
I
like
know.
it, it's okay. Yeah.
I know, but the knowledge of what of some probably boards has some inverted case goes from schematic of this board, because
Yeah,
usually we do not
this
know
is
anything,
schematics.
and I'm not really good in this field of electronics, to be honest. And probably it's better
Yeah,
to test and place from test.
yeah, you can like test it. So let me find photo picture of what we are supposed to get at the end. 1 second. So okay, so the big picture is, so we got this board. We need to get VGA connector. So we need to get the VGA connector, and we need to connect VGA connector using male to female pins to the VGA pins. So we are using a bunch of such male to female wires. and we just put male to here and female to here. So this is VGA. Once we once we connect, so before we start connecting anything, we just need to test this board with some basic examples, with like shift register, with gates and so on. So we need to make sure that when we press buttons, it does like what we expect. Oh, wait a second. Yes, same example. So you just do the same thing you were doing with previous boards. Wait, I need to find the cable for this board. There is no cable. Yeah, let me find the cable. I do have cable. 1 second. So this uses micro USB cable. Okay. Okay, so you are able to run it, right? Are you able? То есть вы смогли опустить примеры какие-нибудь или еще нет? А, понятно, хорошо. Да, ну, в общем, oh yeah, let me give you just a second. Oh, by the way, I think I have extra USB cable, so I will give you extra USB cable. 1 second. Yeah, I think actually this USB cable I have access. So if you don't have USB cable, you can use it. Okay, let me find micro. Find micro USB. Oh, it's here. All right.
Either one of these?
You need to find a specific one. So this should be like one of this. You need to read what. Yeah, here it says blaster, and here it says device something. So it's this one. So USB blaster is okay. Oh, it fell down microphone. So somebody dropped microphone. Okay, so this is.
No, I think that.
Okay, so this microphone fell down from somewhere. Okay. Okay, now let's connect this to 1 second. What is this? Yeah, I think we connected here. I think we connected here. Uh-huh. Okay. All right. Okay. Yeah, so now you know what to do. So now before we continue, let me to show everybody some important thing we did with Philip. So folks, I want to show to like everybody something interesting. So basically I gave Philip a task. We have this VGA game, right? How to make all objects in VGA game 2 times larger. So if we look to what Philip did, so 1 second, let me close everything necessary. So this can be approached in 2 ways, and they want like I wanted everybody to make this exercise, but because like only Philip did, I will show you how this can be done. So one way. So we have a game with sprites, right? So we have graphics. So we have yes, I already integrated it. So we have a game with sprites. So if you connect like a graphic screen, you can actually see how it looks like. So does anybody have this thing working on your table? So do you have? Does anybody have it working? Okay. Пустите просто эту игру, чтобы все видели. Game. Нужно сделать pull request. Okay, so in this game you can see like a small objects. So you can see like a ship and you can see a torpedo which is going to the ship. So now how to make everything 2 times larger? This can be done in 2 ways. So one way, which is like obvious way, is you can make sprites 2 times larger. So you can see like if you go to like original game, and if you go to like sprite display, that's so slow. Yeah, if you go to sprite display, you can see that it has sprites which are like 8 by 8 sprites. So sprite width and sprite height is the 8, and then you instantiate those sprites in a game, and so you make like bitmaps 2 times larger. So here in game top, you like originally they were 8 by 8, and Philip made them 16 by 16, and it works. So if you go to graphics game 2x, so Philip he just changed the different signals. He just changed the different signals widths, so that instead of dealing with like 8 by 8 object, we created 16 by 16 object. Okay, and this is like one way of doing this. So can like anybody come up with like alternative idea how to do this?
Drop the last bit.
Yeah. So alternatively, instead of doing this changes in the bitmaps, you can simply change it in a way by changing of coordinates. So you can go to like laptop and you just like when you have like screen widths, if you have like certain screen widths, you just pass to the module that your screen width is actually 2 times smaller. So you have like two times less horizontal and vertical pixels, and then you also drop lowest bit for X and Y coordinate. And now like all games, because game is supposed to work with any size of a screen, by doing this operation, you kind of tell to game design that you're actually working on smaller screen, and you also get color for each pixel of this smaller screen, which is actually 4 pixels of actual screen. You can get this color 4 times. Yeah, so let's actually run this game on a screen, and you will see like what I'm talking about. So Philip, do you understand this solution, this way of doing things? Yes, Philip, you're on mute. Yeah.
I will try to check it out.
Yeah. So just compare, compare 2-3 game, then 2-4 game is like integrated your code, and 2-5 games this is like different solution. So just do diff between those files and you will figure it out. Yeah.
Okay. Okay. But I also
Okay. So now, just a second. What? Wait, I don't hear. Something is with the microphone. Yeah, can you hear me?
Yes, I can hear you. I'm saying,
Yeah, okay.
I forgot.
Yes, okay.
I forgot to add the row 0.
You forgot to add row 0? Well,
Yes.
just a second.
I think
Yeah, but look, ultimately it modifies picture a little bit, but it doesn't do much change, I believe. So you're talking about that in top, in game top, you didn't add row 0, right? I think yes, you forgot to add row 0. Yeah, but it got like row 0 by default, so it just cut top pixels on the top of a sprite. Yeah,
Yes.
this is fine. Yeah, so since you like already kind of understand how sprite works, you can actually try to make some additional graphical games with like 3 sprites or more, or create some graphics. So what I did like a week ago, I actually entered a competition for TinyTapeout, and let me find this email. So if you go to TinyTapeout website, this is a service which allow you to make your own chip on a silicon foundry. So I actually put 3 orders for 3 different designs, and one of this order is for this game, and they have a special competition called demo scene, and in this competition you can create your own ASIC and connect it to VGA. So they like already sent email with with emulation of this ASIC using basis 3, but eventually they will manufacture and send me back a chip with this game. So in yeah, let me find their email. So like in principle, if you can figure out some like interesting graphical game, I can actually help you to make order for your own chip with them. So just a second, not pen. Yeah, so let me show you how this like demo scene looks like. So like training is such competition is very efficient way to learn Verilog, because you can see like everything you're doing right away. Yes, so this is. So they like create a video, but unfortunately in this video they didn't emulate keys. Why it's not moving? No, it is moving, but but this one is not moving. Yeah, anyway. Yeah, so this is like small object, but by doing this one of tricks, you can do large object. But you can use the same idea to enter their competitions, and you can see different moving objects they are doing in this competition. They are making ASIC chip. So this is like such a moving figure, and meta balls. This internet is slow.
Maybe it's better to download their video.
Yeah, you can like download, yeah. Slow. Yeah, let's try something else. I can connect here to fast internet because they have free Wi-Fi and they have member Wi-Fi. So, oh yeah, you see, this is so long space cowboy. Is it moving or not? No, it's not. I think it also requires pressing keys. Anyway, they will judge this competition when they manufacture everything. Some another demo scene. Yeah. Oh, yeah. You see, this is like nice graphics. You can figure out how to make such nice graphics, and this is actually excellent exercise in combination and sequential logic. So I plan to make entrance every time they get orders for a new chip. So next time this will be end of November. You see, Mandelbrot. Yeah, okay. Okay, so we discussed most of topics for today, and now we just need to work on the boards to make sure that all boards are working. So are you able to
Yeah, I'm trying to run a basic example.
yeah, let's run basic
Yeah.
example. So what kind of error? Can you show me?
It says it cannot find Quartus.
So did you install Quartus?
Yeah, absolutely.
Where is Quartus
It's like
installed?
home Altera 13.1 SP Quartus.
Oh yeah, but you are using older version of Quartus for the older boards, and
Yeah.
this one expects to use new version of Quartus. So in principle,
Okay.
you can use older version of Quartus, but it expects to find new version of Quartus inside Intel FPGA.
So
Yeah, but you don't have Intel FPGA directory. So what you can try to do, you can try to just follow instruction, put different environment variable. So you can put like Intel FPGA. So just before running this, you can put. Let's actually experiment. This is a good way to like experiment. So let's put like export. Intel FPGA home equal to so dollar home, right? Let's see whether it's going to. Oh, sorry. Not the valid. Oh, yeah.
No,
We
you need
should
to
we
clean
should
dash
we
like
should
this.
put export. No. This dash is just fine. Oh, okay. So now it's asking you to check the board. So 21. Okay, now expected to find IntelliFGA Lite or Altera. Okay. So it wanted to find Altera. You can also put Quartus root dir. So let's actually put Altera. I mean, okay. So let's try to put Quartus root dir. Quartus root dir. Quartus root dir equal home Altera slash 13 0 sp1. 13 0 sp1. So if this doesn't work, you can simply install a new version of Quartus in parallel. But if it works, we can do it this way. Okay.
21.
MSC 21. I'm not sure why it's asking. Okay. Wait, home IP. Wait, maybe we should put here without dollar, just home IP.
I'll try to like system
Wait,
variable.
is this like is it bash or C shell?
I guess bash.
Okay,
It's
so
just link.
export. So let's do export Quartus root dir equal IP
Tilde.
home.
Oh,
Yeah,
absolute.
tilde. Let's put absolute pass. So
Mhm.
your
Home
absolute
IP.
pass home IP. Home IP Altera and 13
13 dot. Yeah.
13.sp. Okay, okay. So let's try this one.
21.
Wait a second. Are you on the right branch?
Git branch. Yeah, I guess so.
Yeah. Okay. Git pull. We are trying to use. So we are trying to use old version as a new version. I'm not sure whether. So okay. So expected to find. So let's actually see what it was trying to find. This is a good opportunity to debug.
You can do find comment and like try to see if it's
Yeah. No. Don't do find. We need to debug scripts. So like obviously something is interesting in script. This like experiment whether we can use old version as a new version. So let's go to step and let's see set up inter-FPGA source. First of all,
But
just like for the sake of
Yeah.
testing,
Full disclosure, this is forked repository. Does it make any difference for your script? Should know, right?
did you sync a repository?
Yeah, I did.
No, if you no, this is
Oh,
not
sorry.
going. This is not going to work. If it's
No, I just to explain, like, so this is I have like origin. This is my kind of, and upstream is yours, and I
when you do git pull, it does not get upstream.
Yes, I do git fetch and then git merge upstream. So that's why it has sorry, git log one line. I guess it's like up to date. You see,
Probably
Okay.
you can check
actual
Yeah,
actual status via GitHub.
merges. Yes, it does look merge. It does look merge. From Alexander Ryabov's merge, it does have merge. So yeah, it has merge pull request. So okay, this is fine. So now let's do the following experiment. So experiment number 1. We can create a symbolic link. And the symbolic link, so let's actually go to
Yuri, if it's easier, I can
no,
also
no,
your
no,
original.
no. This is our opportunity to debug this situation.
yeah.
The whole reason what we are doing is
Right.
not to work around,
Yeah.
but to fix bug in our script.
Right,
This is bug in our script. Okay,
I
this
just
is
want to
this is
sure it's
supposed
not
to
bug in my repository, but
yeah, you see. Okay, so wait, so let's create a symbolic link here. So you have Altera, right?
Mhm.
So we are creating symbolic link to InterFPGA Lite.
Mhm.
So ln-s Altera InterFPGA Lite, correct? Okay. So now POP-D. So now let's try to run it again. Wait, why I am running choose another FPGA board? We should run synthesis because we
But you need
did
to pick
choose
the board,
already.
right?
But we already picked the board. Ah, yeah. Let's do
Verilog.
choose another FPGA board. Okay. So choose another FPGA board. Okay, 21. Cannot find any version installed. Okay, so this is something else. So what is it trying to find?
Maybe it's trying to find newer version of Alter.
Wait, this is our script.
Oh,
This is not the script. We need to find bug in our script. Okay. So now, okay, let me actually run. This is Ubuntu,
Debian, yeah.
Debian. So can we run another terminal? Because I want to do
Oh,
this
yeah.
in
You can do plus.
no, but I
Oh,
want
another,
to
totally another.
look,
You can do.
totally another terminal. Yeah.
You can.
Okay, so first of all, I want to see what is the difference between between Altair and InterFPGA. Okay, let me actually see it on my system. So what the script is trying to do. CD. Okay, so I have both Altera. So I have both Altera and I have Intel. Wait, what? Where is InterFPGA? It's installed in OPT. Yeah, so I have InterFPGA Lite.
Maybe it's not installed on my machine yet.
No. Everything should work, okay, because they're the same repositories.
Mhm.
So let's not try to guess because we are controlling the thing. You see?
Yeah.
We are controlling it. So because we are controlling, we just need to find differences. Why it doesn't work? So now Quartus. So what it's trying to do? So we need to debug this particular script. So in the worst case, I mean, no, not in the worst case. So first attempt, symbolic link doesn't work.
Mhm.
So we need to debug why it happens. So now, is it FPGA Lite with a lowercase? Yes, this is with a lowercase. So for some reason, it doesn't work this way. Okay, if it doesn't work this way, fine. Second attempt, we are going to scripts. Okay, first of all, let's make sure everybody know what to do. So, do you know how to run examples? То есть у вас что-нибудь получилось с этим?
Нет, только пока загрузила.
А именно это самое Govin ID?
Да.
Окей. Так, в общем, если у вас есть вопросы, спрашивайте Тимоси или же я. То есть не ждите ничего.
Да?
Потому что... Okay, now, just a second. So, okay, so now let's make sure like everybody knows what to do. So what are you trying to do? Are you trying to like assemble this whole set?
Well, I tried to assemble, it was running about 2 weeks ago. And so now I am not able even to synthesize.
With the latest branch from graphics, new graphics.
Mhm. Yeah. it's
You're
not-
not able to synthesize?
Yep.
Why are you not able to synthesize? Just a moment. So what kind of error are you getting?
Let's check.
This is obviously wrong branch. Yeah, branch. Okay, so what are you trying to do after this? You need to get full. Okay, so this is the old branch. This is branch main. Labs 057 is a branch main. So you are in a wrong place. You need to switch to a new branch. You need to do git. Okay, let me. So if you do cd labs, this like mix of old and new. So git branch. Okay. It shows it new branch. So you need to remove all the old stuff because you have some temporary files. So you do git clean. Git clean dash dot dash d dash x dash n. So you can see that you have like a lot of some like old stuff. Some of the stuff is this. Why do you have something in common?
It's not easy that now you erase the full directory and bring it back again, no, something like that.
I mean, okay, so due to the case of the good stuff.
Yeah.
Okay, so now you're going to one. Wait, go to CD to this one. Yeah, so now you're going to click any exercise, then you run synthesis. So suppose you want to run like this 2 or game or something. So you can run like you want to run the 7-7. Okay, so you're going to 0, so you're going to 1, basics, and then you're to 7, 1, 1, 5. Okay, so now 0, 0, 3. Because they are running two, should run dash.
Actually, I think you need to select it, right?
Oh, you need to run without dot.
Clone everything from scratch.
From scratch. You messed up with a
Unix and DOS
text. In some setting.
I can erase
Let's
everything.
do that. No, in
No,
a new place,
in a new place, clone it from
scratch.
scratch.
Because you see, I can actually show
I can actually show you
what is going on.
what is going on here.
Designer.
So it confused
It's confused
DOS and
DOS
somehow.
somehow.
How does it happen? I
How
have
does it
no
happen? I
clue.
have no clue.
I found it.
Okay, just
Okay,
clone,
just clone fresh
Excuse
place.
me, Yuri, can you help? Can you help? Which one should you download?
Which one should you
We tried
download?
the top one
We
and
tried the
requires a
top-
license.
No,
No,
you got
you
you
got education.
It says
It says
x86.
x86.
Is that okay?
Is that okay?
no, your software.
You are
freelance.
software.
And this is Windows.
And this is Windows.
You are doing
You're
Windows.
doing
Okay.
Windows.
So you're doing
You're
Windows.
doing Windows. Yeah.
Windows
Windows
x64,
there should be education.
I think this is
I
got
think this
this
is
is
got-
confused.
Okay, okay, sounds good. That's it right now. Sound good?
This is 86, yeah.
No, the first part.
Okay,
So
Somewhere in the middle it says education.
Okay. So we should.
O sea, lo que yo pienso es que, o sea, yo estoy de acuerdo que está hecho mierda mi página. ¿Cómo le puedo limpiar lo máximo que puedo para regresar?
Okay, Alexander, so we will test both words, then you tomorrow I don't want to go to the results. Okay?
Yeah.
So if you go.
So have you tried this first of all? This one?
Educational, yes.
Okay, because I haven't tried it yet, so. I need to know.
Okay, so we are doing some code debug, so we are. Disconnected.
Y los dos valen para una chingada. Lo mejor que hay que hacer es borrarlos, cabrón. Porque si ya-
I'm documenting the stuff.